Hello, welcome to the very first recording session associated with the Statistical Methods for Engineers and Applied Scientists course. This recording session kicks off the Introduction to Probability. Within that, we have 4 different recording sessions, and this is the first focused on basic concepts in probability. So basically, let's get warmed up and kicked into probability. So why study it? Well, I think I think even kindergartners would say, well, of course we've got to study probability. It's everywhere in our lives. You talk about global warming. Might be interested in what's the chance of 100 plus temperatures for the next 30 days. Or what's the probability that there will be at least 90 days in the Dallas-Fort Worth area that have 100 plus temperatures next year. What's the chance of a new strain of swine flu in the United States or anywhere in the world? As we get into medical research, pharmaceutical, of course they're going to have interest in probabilities. Investment arena, financial areas. What's the chance that the Dow Jones Industrial Average will go up on Monday? Okay. What's the chance that a project change will delay completion? So again, if you're talking about multi-million, multi-billion-dollar projects, and they take 3 years to, let's say, build an oil rig or build a major construction project that is going to take many years, if there's a small change that's occurring very early in the project, how's that going to impact the completion of the project long term? You might want to be able to do some analysis on that, and probability will certainly come into play there. What's the connection between seniors and rap music? So marketing, advertising, of course, those fields are interested in probability because, and this is actually an actual example where they did an analysis and found out that, thinking about it, of course, seniors buy gifts for their grandkids typically, and if they have them, and turns out that this was the case, that it was a tremendous bonus to go ahead and advertise rap music or other things that seniors would buy for their grandkids. And they put some numbers to it. You know, they did a quantitative analysis to help the decision making on the advertising front. Why study probability? Of course, the job market. Lots and lots of, these are just a few of the different skill sets that people are looking for and job types that require a solid foundation in probability and statistics. So what is probability? The study of randomness, the study of uncertainty, and that's our lives. So that's part of the permeating our lives. Theory of probability provides methods for quantifying the chances or likelihood associated with various outcomes in any situation. Most of the time, and this is simplifying it, but two key types of studies or applications of the probability, the way that it's used would be, one is you hypothesize a model and use it for practical purposes. So you assume something from a probabilistic standpoint. So in this case, I'm talking about the random behavior of arrival times and service and treatment times for patients entering a medical clinic. Okay, that's uncertain for an ER room, let's say. It's uncertain when someone will arrive, what kind of treatment they'll need, but you can look at historical data and then say, okay, on average on Sunday afternoon, we have these kind of things in this particular neighborhood. And you would then, so one application would be assume a specific model about arrival rates, probabilities associated with what kinds of treatments will be needed or what a patient walks through the door with, broken leg or strep throat or whatever. So you assume a certain model, and then you make some decisions off of that. You base your decisions on, or in this case I'm talking about physical layout of the building, but it could be a day-to-day thing as much as scheduling physicians to be physicians or x-ray technicians or whoever, receptionists coming in for the front door, all of that kind of stuff. You assume a probabilistic model and then make decisions off of that. The second way that is indicated down here is determining if a hypothesis model is correct. So let's say we assume that on Sunday afternoons, here's average arrival rate will be 6 per hour for this particular hospital ER, and the probability is 0.3 that any of those patients will need to have an X-ray performed. Maybe that's the high time of kids' sporting events, so there's a higher rate of breakage, bone breakage, or something like this. So that could be, that's your probabilistic model. Your study might be focused on, well, is that accurate or not? Is that reasonable? Because if you go basing all of your staffing considerations, the layout of a facility, all that kind of thing, on your assumptions about the probabilities, you want to make sure that those are good. It's a good model that you're hypothesizing. So some basic questions around probability. First is the question, what do you mean by a probability is 0.82, 0.25, 82%, 40% chance of rain today? What does that mean? Then there's the question of how to obtain the numerical values for probabilities. How do you figure out? So where did that 40% chance of rain come from? Where did if you go to Las Vegas, you got a 1 in 100 chance of winning a particular card game. Where does that 1 in 100 probability come from? How do you obtain that probability? And finally, there's the question of how probabilities can be combined to obtain other probabilities. Can we derive a probability based on some other probabilities that we know about? And we're going to be looking into each one of these. To kick it off, let's look at this poor mathematician. I admire that he had the tenacious drive to do this, but during World War II, flipped the coin 10,000 times and tallied the results. So flipped it 10 times and noted that he had 4 heads. Relative frequency then would be 4 over 10 or 0.4. Flipped the coin 100 times, got 44 heads. Relative frequency, 44 over 100. Flipped the thing 1,000 times and 502 and so forth like this. But so here you have all the way to 10,000 flips. And I don't know. It amazes me that someone can keep track. That's very focused. To keep track of how many specific heads he had out of 10,000 flips. And a relative frequency on that experiment was 0.5067 then. So, in terms of the question, how do you derive a probability? Well, this could be one as a very good estimate that the probability is 0.5 that you'll have a head. So to get our terminology, kind of make sure we're all on the same page, we define experiments, a well-defined action. It is any action or process that generates observations. So when we say this is the experiment, we want to be very clear. Okay, my experiment is to flip a coin 10 times, and I'm going to mark down how many heads I get. My experiment is to buy 5 lottery tickets in this week's lottery and determine what's the probability of getting a winning number, or getting a winning ticket, I should say. I think the lottery has about 6 numbers to it. So what is the experiment? You want to be very specific about what action you're taking. The next definition is an outcome, the result of performing an experiment. So if I'm going to flip a coin 10 times, an outcome on each one of my flips is either heads or tails, right? On each one of those 10 flips. Definition, sample space, the set of all possible outcomes of a random experiment, and is represented by the capital letter S. So let me go right into, so example, an experiment is to roll a 6-sided die. The list of all possible outcomes that could happen on that one roll would be, I roll a 1, I roll a 2, I roll a 3, 4, 5, 6, right? On one roll, I could roll any one of these. Experiment is the nurse measuring patient's height. Then if rounded to the nearest inch, if the heights are rounded to the nearest inch, the heights could be 1 inch, 2 inch, 3 inch, so forth. Or it could be a continuous, where you're saying it could be any height, and it just has to be, of course, something that's greater than 0. Okay, throughout these recordings, you're gonna see slides that talk about a learning checkpoint. This is learning checkpoint 1 associated with the probability sessions, and here's the checkpoint. An experiment consists of tossing a fair coin 3 times in sequence. List all outcomes in sample space S. How many outcomes are there in sample space S? All right. My assumption is with these learning checkpoints, you might actually pause the recording, go and try and work out the solution for these questions. And then on, again, the course Blackboard, you will find the course outline. You'll have on the course Blackboard, you will find an additional PowerPoint that says learning checkpoint, probability learning checkpoint solutions. And so in there, you'll actually find the answers to all the questions I posed. So in this case, there is a slide over in the probability learning checkpoint PowerPoint deck. The answers to this question: experiment consists of tossing a fair coin 3 times in sequence. List all the outcomes in the sample space. So I could get a head, and then a head, and then a tail on my third flip. I could get a head on my first flip, tail on my second flip, head on my third flip. And so these are each of these is a possible outcome of 3 flips of a coin. And I note that there are 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes in my sample space S. Okay, some additional probability terminology. Definition: an event. An event is a set of outcomes of the sample space, each having a given characteristic or attribute. Note that an event A is a subset of the sample space, S. So I could, for example, say, well, out of those 8 events or outcomes that we looked at in the sample space of flipping a coin 3 times, an event might be that I flipped exactly 1 head. And if I go back and say, okay, so how many of these outcomes match to the event of 1 head? So this one, the TTH, THT, HTT. Those are 3 different outcomes that satisfy my characteristics of the event that I flipped just 1 head. I could also specify and say, so that would be an event that is actually a compound event, in that there were a union of simple events. So a simple event is that there's only 1 outcome associated with it. So if I had said my event definition, event A is that I flipped 3 heads. There's only 1 outcome in that set of 8 that match that. But the fact that I picked and said, okay, and if I call my event A that I flipped 1 head at exactly 1 head, then the outcomes I saw that there were 3 that matched to that. The null event is one that doesn't have any outcomes that match to it. So it's kind of a goofy one, but null event might be that I got 4 heads. Not possible. So, or the outcomes that match to 4 heads wouldn't be possible if I only had 3 flips. Okay, so and some examples. 6-sided die event, event A. So if I roll a die 1 time and it's 6-sided, so event A is defined as a roll that has an even number. So outcomes in my sample space that match to event A would be if I rolled a 2, if I rolled a 4, or if I rolled a 6. Event B is defined as roll an odd number, so therefore 1, 3, or 5. Event C is defined as a roll a number greater than 4.